Welcome to the next lesson in our block on hydraulics and pneumatics. We've been looking so far at the subject of pneumatics, which is specifically pressurized air. And so today we're going to be taking the second portion of this block and begin discussing the idea of hydraulics and what are they. So with pneumatics, of course, we started talking about the ways that we can pressurize air, the ways that we can move pressurized air, different uses of pressurized air. And today we're going to move on because pneuma is the Greek word for air. Today we'll be moving on to hydraulics, which is the Greek word for water, and in particular, water and pipe. So the Greeks gave us this word to describe in particular the movements of liquids. And so just as pneumatics is a study of air, hydraulics would be then the study of liquids. Now, both of these can be identified as the way that pressure affects fluids. Now, normally when we think about the word fluid, we imagine that we're talking about a liquid. But in fact, fluid actually refers to matter in any state that it can be shaped, that it does not contain a fixed shape. So whether it's air, a gas, or a liquid, or even plasma, matter that is fluid can actually change its form and in fact is influenced by outside pressure upon it. So of course the type of matter that is not influenced, that maintains its shape, would be solids. So just like when I knock on the chalkboard, it retains its shape, it does not get affected. That would tell us that it's the state of matter of being a solid. So we're talking about right now the type of fluid that is liquid. Now we're going to break up our study of hydraulics into two different types of liquids. We have oil and water. So we know what water is. It's of course two hydrogens and an oxygen. It's a basic state of matter. Or water in its natural state can be either liquid as water as we think about it, or when it is cooled down it becomes ice, a solid, or when we heat water, of course, it evaporates and turns into a gaseous form. So water is a basic type of liquid, and we've already studied it quite a bit. But let's talk a little bit today about oil as well. Oils are going to be our second study of hydraulics. Now, an oil refers to a liquid that is made of, a variety of different things that is not a water or water-based. So we have a lot of different types of oils. For example, we have organic oils, in which we could think about olive oil or vegetable oil or coconut oil, things where we are taking plant matter and we are squeezing them or putting them under pressure until they release a liquid. And the liquid released is, of course, an oil. Other types of oils are mineral oils, and they can be made from a number of different things. Sometimes lumped into the mineral oil category, we would think about things like hydrocarbons. When we hear about oil, all too often right now, we think about the hydrocarbon of petroleum. Now we know that even though we would think of it as an artificial oil, or not really artificial, we would not think of it as organic necessarily, but in fact, hydrocarbons do come from organic material originally. That's how they store their energy. So we can see that oils have a lot of different functions. We could use oils to cook with. We can also use oils to power things. Oils have a tendency towards being flammable, most of them. And one of the last things that we would think about is that oil and water don't mix. So oil is something that we would call hydrophobic, meaning it does not saturate itself with water, it does not mix with water. Oil is a totally separate substance. We'll be coming back to the hydraulics of oils in the next lesson. But today we're going to start talking about the hydraulics of water. So hydraulic is a pretty open term in talking about all these different ways that water moves and how outside pressure can affect liquids like water. When we first start thinking about hydraulics, one of the ways that we can imagine is that humans have been using hydraulic power for a very, very long time. The water wheel, of course, is one of the earliest ways in which humans were able to look at something like a stream or a river and determine that it contains energy. The moving of that water has a certain amount of energy. And so if we're able to put something in that moving water that allows the water to move it and to turn it, we can transfer that power from the water itself into some other function. And so water wheels have been running all kinds of mills to either crush grain, for textiles, and then of course for a lot of other purposes later, including sawmills. So hydraulic power is something that we would use that term for, and that is converting the energy of flowing water into another type of usable energy. Now, currently, when we think about hydraulic power, a lot of it that we get these days is coming from hydroelectric dams. So we can also imagine that that stored energy in moving water can be blocked off by a dam, and then by allowing that water to flow through a turbine or a small type of a water wheel, we can actually channel that through a focused little chamber, or a little way that we concentrate that energy. And then, of course, we produce hydroelectric power. So these are different ways that hydraulics actually contribute directly to the production of energy. And today, we're going to look a little bit more at how hydraulics exist in our everyday life. And so I'm going to go very specifically into the home. How do we have pressurized water at home? Because that's our most common experience with hydraulics, is by turning on a faucet or taking a shower. So how does your water system work within your house? That's our question for today. Well, here in Hawaii, we have a lot of different ways that people can get their water into their house. This can be true all over the country, but in particular, Hawaii is a place that a lot of people, like myself, live off a system called catchment. Now that would mean that we are catching the water off of our roof, directing it through a series of pipes into a tank, and then storing that water in the tank until we want to use it. Well, catchment can provide from the tank to the house system. It can provide water in two different ways. We could have a pump that runs into the pipe that goes into the tank, and the pump can pull the water out and send it into the house system. Or we also know that with a catchment tank, if we put the tank at a sufficient amount higher than the place that we want to use the water, we can actually use the strength of gravity to create pressure in the system. So as long as the tank is higher and the water is flowing downhill, that will create a certain amount of pressure that will go into your household system. Now, another way that people will get water into their system can include a municipal system. Municipal refers to a town or a city, somewhere that water is generally being cleaned and is being distributed to the people who live together in a city. Well, that's going from wherever they're producing this water, or where they're cleaning and filtering and getting it ready, and it travels through a series of what we call water mains. The water mains are big pipes that run around the city, and then of course come up to individual houses, where they'll have a valve that can turn the water on or off from the main. In a municipal system, the water is already pressurized in those pipes, and so we don't need extra pressure to pull that water into our home. The pressure of that system is going to go ahead and do that job for us. Another way that we can get water into our house is, of course, through a well. And a lot of people around the world have their water from sources that they dig a well and they add a water pump to the system. So, in order to get a well that is functioning, you have to live in a place where you can dig a hole down, or a well, to a point where you hit what we call the water table. And the water table refers to that level underground where the water is sitting usually on some form of bedrock, clay, some other surface below the crust, and the water basically stacks up upon itself. When there's enough water in an area below ground, we call it an aquifer. And an aquifer then refers to a certain amount of water that is sitting almost underground as like a giant lake. A lot of this water is obviously coming and filtering down through the rocks until it hits a level where there's enough water sitting down there that it can create a water table. So if we have a well, we're going to go ahead and put a pump, and we're going to run a line down until we hit a pipe that is going to go down, and we're going to hit that water table when we get it deep enough. So the water pump is going to work very similar to the mechanism that we talked about when we discussed air compressors. Generally, water pumps have the idea that they're going to create a vacuum by using a piston. When the piston drops down in its cylinder, it is going to open up a valve on the outside. That valve will allow water to travel into the piston. Now, of course, in the air compressor, it's the same thing, but air is coming in. When the piston moves back upward, it's going to now create pressure inside that chamber. And that pressure is going to close the valve that allowed the water or air to come in the first place, and is going to force the water out another valve that's going to go off to a system. So in this case, the water is moving up into the cylinder of the piston and then is being forced down a line into the house. Now you notice with each of these, there's always a shut-off valve so that we can cut off the water supply if we need to do work on the house. If you had to work on your plumbing, you'd want to shut off your water supply so that when you open up your pipes, they don't go spraying everywhere. So once we get our water to our home, one of the first things that we see is something that is called a check valve. And a check valve is a valve that's designed to be a one-way valve. It allows water into a water system, but then when the water wants to go back out, the valve will shut off. And so a check valve allows us to pressurize a water system, and when we add pressure to the pipes of this water system, we're not just shooting that water right back into our catchment tank or to the water main or to the well. So the check valve allows water in to be pressurized, but won't allow it to go back out. After we leave our check valve, we're going to go into another part of the water system. Now, many water systems around here, for example, ones with catchment tanks, will have a pressure tank attached to your system. A pressure tank is very similar to an air compressor in the sense that we're using a rubber bladder in order, and the flexibility of that bladder allows us to adjust the amount of air pressure inside this tank. And so the tank is a combination of air pressure and pressurized water that have to do with how much pressure sits above that bladder. So above the bladder in our water pressure tank, we have a little valve that allows us to actually adjust the amount of air pressure for this system. Now the pressure that's contained in that tank allows the entire rest of the water system to have water pressurized in all the pipes. Most of these systems also have some form of a pump. This is going to be very similar to the pump that we were bringing water out of the well with, but in this case, the pump is either bringing water into the system and oftentimes pushing it through the whole system if need be. Any time that the water pressure drops below a certain level, the pump will kick on and repressurize the system until it's at the PSI that we want, or the pounds per square inch. After we've got our system all pressurized, the next location that our water is going to go is it's going to go through a pipe and enter into a water heater. Now, there are a couple of different types of water heaters. The traditional type of water heater that many houses still have has a cold water line coming in from the system that goes into a large cylinder. This cylinder is insulated so it can maintain heat, and inside this cylinder there is some sort of heating element. This heating element is either powered by gas, there are sometimes gas water heaters, or it can be powered by electricity. Either way, it's the same effect. there is essentially a metal coil on the inside that gets very hot, keeps the water heated to a certain temperature, and then the water is able to go out into the system and maintain hot water. There is also a system called on-demand water heaters, and in that case, the cold water is running through, but every time we open up a hot water valve, the water runs through a very tightly packed system of copper coils, and the water is heated in that moment. So it's called on demand because the hot water is only being heated when you actually use it. The difference would be that with the traditional water heater, it's storing hot water for a long time, and therefore that stored water, if we're not using it, can lose its heat. So there can be a waste of energy in that sort of a system. So when a pipe leaves our water heater, we can see that in this example, I've drawn it as a copper pipe. Generally, we will run hot water through a different type of pipe. And that's because we want to keep that insulated. We want to use a different system than we might have used bringing water in. Perhaps we used PVC coming into it, but with hot water, we generally want to go out with copper. Now, where does it go? Well, we now have pressurized water, and we have half of our pressurized water hot. So both of these lines are eventually going to go to all of our fixtures. And all of our fixtures in our household water system are a series of valves. When we look at your average faucet, whether it's in your kitchen or whether it's in your bathroom, your faucet is a set of two different valves. You will have the water line coming in from the hot, and you will have the water line coming in from the cold. It is regularly set up so that the hot will be on your left and the cold will be on your right. That's standard plumbing. Now, each of these levers, or sometimes you'll have a central lever that'll operate both, they both have the situation where there is a rubber disc that as you open up that valve, the rubber disc loosens itself up and allows the water to flow through. However much we open that valve will allow a different amount of water through. If we want more hot than cold, we'll open the hot. That will allow a greater amount of hot water to come in, and it will mix with the cold water that we allow in. So essentially, each of these temperatures of water are coming together, and they're meeting inside the faucet and coming out at the temperature that we're hoping for. Well, that's a similar mechanism if we want to have a shower. In the case of a shower, we will have, again, a cold line that will come in, and we'll have a hot line that will come in, and they meet in something that we call the shower mixer. So the shower mixer, once again, is a valve that we can open up, and we can determine how much hot and how much cold water we want to mix in our system. In a traditional shower mixer, we have an outlet that goes down, and we know that water always wants to seek the lowest place. And so, once we have opened our valves and allowed the water to travel into the system, it will go down and flow into our tub. And it'll keep flowing into our tub unless we decide that we want to put a stopper on. The stopper is, again, another type of a valve. It shuts off the water flow at the tub, and by blocking that, now the water is forced back up the tube and out through the shower head so that we can enjoy a nice warm shower. The last place that our water is going in this system is a cold line will run off to our toilets. Now, a toilet obviously doesn't need a hot water line to it, so it's only going to have one feed, just a cold line. Now, the cold water is going to go in and enter into a storage tank, which once again, like our catchment tank, is sitting up above the actual bowl of the toilet. Therefore, we're again going to use gravity to allow that water to go through and clean out the bowl of the toilet. Well, once it enters into the bowl, there's a valve inside every toilet, so that when we flush, when we pull the lever, we are lifting a flap inside the water tank and allowing all the water stored up here in our storage to go down and flow through the toilet and then work its way out into the sewage system. Once that water is all drained out of the upper tank of the toilet, there is a slow-moving system that will go up as the new water enters, because once that arm goes down, it has opened the valve so that water can enter the tank. Now, once that happens, it's going to continue filling until we get to the appropriate level. There will be either a ball inside there or some sort of thing that when it gets to a certain level, it shuts off that valve once again. So all of these things are working together to create a pressurized hydraulic system. Again, hydraulics refer to the idea of water under pressure. So I hope that this gives you a little insight into how things work within your house and how we're able to get pressurized water all over our household systems. Tomorrow, we will come back and we'll start looking at the hydraulics of oil and systems that we might run off of pressurized oil.